Hello, in this lecture we will find the area of the green triangle. In the drawing we have triangle ABC, that is an equilateral triangle, and inside triangle ABC we have the green triangle FDE, that is actually a right triangle because angle FDE of the green triangle is a right angle, and we know that AF equals to BF, BD equals to 2 units, and DC equals to 4 units, and we want to find out the area of the green triangle FDE. Okay, first of all, we know that the angles in any equilateral triangle, all the angles equals to 60 degrees, so angle BAC equals to 60 degrees, and also angle ABC equals to 60 degrees, and also angle BCA equals to 60 degrees, and we also know that in any equilateral triangle all the sides are equal to each other, so actually AB equals to BC equals to AC. Again, in the equilateral triangle ABC, all the sides are equal to each other. That is to say, AB equals to BC equals to AC. Okay? But what is the value of side BC of the equilateral triangle ABC? The value of BC is actually BD plus DC. Again, BC equals to BD plus DC. But we know that BD equals to 2 units and DC equals to 4 units. So BC equals to B, that is 2 units, plus DC, that is 4 units. So actually BC equals to 6 units. Okay, so actually all the sides of the equilateral triangle ABC equals to 6 units. Okay, and we also know that AF equals to BF. If we define AF as X, then BF that equals to F, BF that equals to AF also will be defined as X. So what is the size of AB? The size of AB is actually AF plus BF, because AB equals to AF plus BF. So actually AB equals to AF, that is X, plus BF, that is also X. In other words, AB equals to 2X. Okay, you can write that for one side AB equals to 2X, but from the other side we have already found out that the AB equals to 6 units. Okay, AB equals to 6 units, so we can derive this equality from the big equality and from this equality. So we can say that 2x equals to 6 units, and 2x equals to 6 units, and if we divide this equality by 2, we will get that x equals to 3 units. So x equals to 3 units, that is to say AF equals to 3 units, and x also here equals to 3 units, so BF also equals to 3 units. Okay, in the next step we will define FD as A, that is to say FD equals to A, and we will define DE as B, that is to say DE equals to B, and we will find the value of FD according to the law of sines. Okay, what is the law? We will find the value of FD, that is also equals to A, according to the law of cosines. Okay, what is the law of cosines? The law of cosines apply to any triangle. We can use the law of cosines in any triangle, so we can write here that in any triangle if we have triangle if the length of this side of the red triangle is A, the length of this side of the red triangle is B, and the length of this side of the red triangle is C, and the angle between side A and side B of the red triangle is theta, then according to the law of cosines, the following relationship exists between the sides of the red triangle to angle theta. C square equals to A square plus B square minus 2 times AB times cosinus theta. Again, in any triangle, C square equals to A square plus B square minus 2 times A times B times cosinus theta. Okay? C square equals to A square plus B square minus 2 times A times B times cosinus theta. So we actually can implement the law of cosines in the small triangle BFD, this triangle. In the small triangle BFD, according to the law of cosines, FD square equals to fb squared plus bd squared minus 2 times fb times bd times cosinus 60 degrees. Again, in the small triangle FBD, FD square equals to FB square plus DB square minus 2 times FB times BD times cosinus 60 degrees. Okay? So, what is the value of FD? FD equals to A according to our definition, so FD square is A square equals to FB square. FB equals to 3 units, so FB square is 3 square is 9 plus BD square. BD equals to 2 units, so 2 square is 4 minus 2 times FB is 3 units and BD is 2 units. FB times FD times cosinus 60 degrees. Cosinus 60 degrees is 1 over 2, so in total we got that A square equals to 9 plus 4 minus 2 times 3 times 2 over 2. 2 over 2 is 1, so 4 is cancelled. So in total we got that A square equals to 9 plus 4 is 13 minus 2 times 3 is 6. So in total we got that A square equals to 13 minus 6. 13 minus 6 is 7, so we got that A square equals to 7. Now we will take a root out of this equality and we will get that A square equals to root 7 units. A square equals to root 7 units. A square equals to 7, so A equals to root 7 units. So here we can write that A equals to the root of 7 units. Okay. In the next step, we will define angle BFD as theta, angle BDF will be defined as alpha, angle CDE will be defined as gamma, and angle DEC will be defined as beta, and we will find out the value of sinus theta according to the law of sines. Okay, what is the law of sines? the law of sines apply to any triangle. So we can write here that in any triangle we can use the law of sines in any triangle. If we have triangle if the length of this side of the red triangle is A, if the length of this of this side of the red triangle is B, and if the length of this side of the red triangle is C, if this angle is angle alpha and this angle is angle beta and this angle is angle gamma, then according to the law of sines, the following relationship exists between the sides of the triangle to the angles of this triangle. According to the law of sines, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Again, in any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay? So, we actually can implement the law of sines in the small triangle FBD. In this small triangle FBD, we can implement the law of sines. So, in triangle FBD, BD over sinus theta equals to FD over sinus 60 degrees. Again, according to the law of sines, or the implementation of the law of sines in triangle FBD, is BD over sinus theta equals to FD over sinus 60 degrees. BD over sinus theta equals to FD over sinus 60 degrees. So, what is the value of FD? FD equals to A and A equals to root 7 units. We've already found out that the A equals to root 7 units. So, we can substitute BD by root 7 units, and sinus theta is the variable that we want to find out. So we will leave sinus theta as it is, equals to FD equals to BD, that is 2 units, again, triangle FBD So I will repeat again. BD over sinus theta equals to FD over sinus 60 degrees. The value of BD is 2 units and sinus theta is the value that we want to find out, so I will leave sinus theta as it is. All equals to FD. FD is actually A, that equals to root of 7 units over sinus 60 degrees. The value of sinus 60 degrees is root 3 over 2. So in total, we got that 2 over sinus theta equals to root 7 over root 3 over 2. So here we can move 2 to the numerator and root 3 to the denominator. So we will get that 2 over sinus theta equals to root 7 times 2 over root 3. So we got that 2 over sinus theta equals to root 7 times 2 over root 3. Here we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of the other side of the equation, so we can cancel 2. And what is left after we cancel 2? One over sinus theta equals to the root of 7 over root 3. So after we cancel 2, what is left is 1 over sinus theta equals to root 7 over root 3. Here we will multiply this equality by sinus theta, and we will get that 1 equals to sinus theta times root 7 over root 3. So after we multiply this equality by sinus theta, we got that 1 equals to sinus theta times root 7 over root 3. In the next step, we will multiply this equality by root 3. And we will get that root 3 equals to root 7 times sinus theta. Okay, we got that root 3 equals to root 7 times sinus theta. In the next step, we will divide this equality by root 7 in order to get the value of sinus theta. So we will get that sinus theta equals to the root of 3 over root 7. Okay, we divided this equality by root 7 and we got that sinus theta equals to the root of 3 over root 7. Okay, in the next step we will find out the value of cosinus theta by implementing the first trigonometric identity trigonometric identity states that sinus theta squared plus cosinus theta squared equals to 1. Okay, according to the first trigonometric identity, sinus theta squared plus cosinus theta squared equals to 1. In the next step we will subtract sinus theta squared from this identity and we will get that cosinus theta squared equals to 1 minus sinus theta squared. Okay, we subtracted sinus theta squared from this identity when we got that cosinus theta squared equals to 1 minus sinus theta squared. In the next step we will take a root out of this equality and we will get that the value of cosinus theta equals to the root of 1 minus sinus theta squared. Okay, we got the value of, we took a root out of this equality and we got that the value of cosinus theta equals to the root of 1 minus sinus theta squared. But we have already found out that the value of sinus theta is root 3 over root 7. Okay, so we can write that sinus theta equals to the root of 3 over root 7 but if sinus theta equals to the root of 3 over root 7 then sinus theta squared will be equal actually we will square this equality and we will get that sinus theta squared will be equal to 3 over 7. So we can substitute sinus theta squared by 3 over 7 equals sinus theta squared equals to 3 over 7. So we will get that cosinus theta equals to the root of 1 minus 3 over 7. We substituted sinus theta squared by 3 over 7, and we got that cosinus theta equals to the root of 1 minus 3 over 7. So cosinus theta equals to the root 1 minus 3 over 7 is 4 over 7. Okay, so we got that the value of cosinus theta equals to the root of 4 over 7. The root of 4 is 2, so I write it down. So cosinus theta equals to 2 over root 7. The root of 4 is 2, so we got that cosinus theta equals to 2 over root 7, and we have already found out that the value of sinus theta equals to the root of 3 over root 7. Okay, in the next step we will create 4 equations from this drawing. We will focus on triangle BFD. On triangle BFD, the sum of its angles equals to 180 degrees, so that will be our first equation that states that the sum of the angles in the small triangle FBD equals to 180 degrees. What are the angles? The sum of the angles in triangle FBD is actually 60 degrees plus alpha plus gamma plus alpha plus theta, and the sum of those angles equals to 180 degrees. Okay, so that is our first equation that states that the sum of the angles in the small triangle FBD or BFD equals to 180 degrees. Then we will focus on triangle DEC, and on triangle DEC we can say exactly the same thing, that the sum of the angles of triangle DEC equals to 180 degrees. What are the angles of triangle DEC? Is actually 60 degrees plus gamma plus beta. And the sum of those angles equals to 180 degrees. Okay, the second equation states that the sum of the angles in the small triangle DEC equals to 180 degrees. In the next step, we will add equation number 1 to equation number 2, and we will create equation number 3. Okay, so equation number 3 is actually the addition of equation number 1 to equation number 2. Okay, when we add equation number 1 to equation number 2, we will get equation number 3, that is actually 60 degrees plus 60 degrees equals to 120 degrees plus alpha plus theta plus gamma plus beta equals to, in the other side of those two equations we have 180 degrees plus 180 degrees equals to 360 degrees. In the next step, we will subtract 120 degrees from equation number 3, and we will get that alpha plus theta plus gamma plus beta equals to 360 degrees minus 120 degrees equals to 240 degrees. Okay? And in the next step, we will create equation number 4. And equation number 4 states that if we focus at a certain point at a straight line or line segments, here if we focus on line segment DC at point D, you can say that the sum of the angles at the upper side of line segment BC equals to 180 degrees. Okay, the sum of the angles at the upper side of line segment BC at point D equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Again, if we focus at a certain point at a straight line or line segment, the sum of the angles at the upper side of any straight line or line segment equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, so this is our fourth equation. In the next step, we'll subtract 90 degrees from the fourth equation, and we will get that alpha plus gamma equals to 90 degrees. Okay, so according to the fourth equation, alpha plus gamma equals to 90 degrees. Okay, but we have alpha plus gamma also in the third equation. We have here alpha plus gamma in the third equation, so we actually can substitute alpha plus gamma in the third equation by 90 degrees, because alpha plus gamma equals to 90 degrees. Okay, so we will substitute alpha plus gamma by 90 degrees in the third equation, and we will get that (90 degrees plus theta plus beta equals to 240 degrees. Okay, so in the third equation we got that 90 degrees plus theta plus beta equals to 240 degrees. Here we will subtract 90 degrees from the third equation, and we will get that theta plus beta equals to 240 degrees minus 90 degrees is 150 degrees. So we got that theta plus beta equals to 100 and 150 degrees. But if theta plus beta equals to 1, here we will subtract theta from equation number 3, and we will get that beta equals to 150 degrees minus theta. We got that beta equals to 150 degrees minus theta, but if beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. Okay? So we can write down that sinus beta equals to sinus 150 degrees minus theta. Here, in order to find out the value of sinus 150 degrees minus theta, we will use the second trigonometric identity that states that the value of sinus alpha minus beta is actually sinus alpha cosinus beta minus sinus beta cosinus alpha. Okay, so according to the second trigonometric identity, sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Here we will substitute alpha by 150 degrees and beta by theta in order to find out the value of sinus 150 degrees minus theta. And we will get that sinus 150 degrees minus theta equals to sinus 150 degrees times cosinus theta minus sinus theta times cosinus 150 degrees. Okay, so we implemented the second trigonometric identity in order to find out the value of sinus 150 degrees minus theta. when alpha equals to 150 degrees and beta equals to theta. Okay, so what is the value of sinus 150 degrees? The value of sinus 150 degrees is 1 over 2. And we have already found out the value of cosinus theta. The value of cosinus theta is 2 over root 7. Here we have minus sinus theta. We have already found out that the value of sinus theta is root 3 over root 7. Times cosinus 150 degrees. The value of cosinus 150 degrees is minus root 3 over 2. So in total we got that 1 over 2 times 2 over root 7 minus root 3 over root 7 times minus root 3 over 2 equals to sinus 150 degrees minus theta. That is actually equals to sinus beta. Okay, here we have 2 in the numerator of this expression and we have 2 in the denominator of this expression, so we can cancel 2. And we have here minus times minus, minus times minus is plus, and root 3 over root 3 is 3, so I'll write it down. So we got that 1 over root 7 minus times minus is plus equals to 1 over root 7 times 3 over 2. Okay, so we have here 1 over root 7 plus 1 over root 7 times 3 over 2. And that is actually the value of sinus beta. Here we will take out 1 over root 7 as a common factor of this expression, and we will get that the value of sinus beta equals to 1 over root 7 is the common factor of this expression, and inside the brackets we will have 1 plus 3 over 2. Okay, so we got that sinus beta equals to 1 over root 7 and times, in the brackets we have 1 plus 3 over 2, and 1 plus 3 over 2 is 2.5, and 2.5 is 5 over 2, so I write it down. We found out that the value of sinus beta is actually 1 over root 7 times 5 over 2. Okay, the value of sinus beta is 5 over root 7 times 2. Okay, so after we found out the value of sinus beta, we will use the law of sines in order to find out the value of b. The value of b that is also db. Okay, and after we will know the value of b, we can calculate the area of the green triangle, because the area of the green triangle equals to the base of the triangle that is b times the height to the base that is a over 2. Okay, after we will find the value of b, we will actually know the area of the green triangle. So we will implement the law of sines in the small triangle DEC. So according to the law of sines, in the small triangle DEC, DC over sinus beta equals to DE over sinus 60 degrees. Again, according to the law of sines, in the small triangle DEC, DC over sinus beta equals to DE over sinus 60 degrees. DC equals to 4 units, and we have already found out the value of sinus beta. The value of sinus beta is actually 5 over root 7 times 2, or 5 over 2 times root 7 equals to DE. DE is actually the missing variable. DE equals to B over root 60 over sinus 60 degrees. The value of sinus 60 degrees is root 3 over 2. So in total we got that 4 over 5 over 2 times root 7 equals to b over root 3 over 2. Here we will move 2 times root 7 to the numerator, and we will move 5 to the denominator, and here we will move 2 to the numerator, and we will move root 3 to the denominator, and we will get that 2 times root 7 times 4 over 5 equals to 2b times root 3. So after doing the simple arithmetic calculation, we got that 2 times root 7 times 4 over 5 equals to 2b over root 3. Here we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of the other side of the equation. So we can cancel 2, and what left after we cancel 2 is root 7 times 4 over 5 equals to b over root 3. Here you simply multiply this equality by root 3 in order to get the value of b. Okay? So we will get that the value of b equals to root 7 times root 3 times 4 over 5 units. Okay, so we got that the value of b is root 7 times root 3 times 4 over 5 units, and we have already found out that the value of a is root 7 units. Okay, a equals to root 7 units, and again the area of the green triangle FDE equals to the base of the triangle, that is b, times the height to the base, that is a, over 2. Okay, the area of the green triangle FDE equals to b times a over 2, or a times b over 2. Again, the height must create 90 degrees with the base b, and the height a indeed creates 90 degrees with the base b, because angle FDE equals to 90 degrees, it is a right angle. So we have already found out the values of a and b, so we can substitute a and b in the formula for the area of the green triangle FDE, and we will find out the area of the green triangle FDE. Okay, so the area of the green triangle FDE equals to a times b over 2 a times b over 2 is the area of the green triangle FDE. We have already found out that the value of a is root 7, and the value of b is root 7 times root 3 times 4 over 5, and we divide all by 2 because it is b times a over 2. So actually the area of the green triangle FDE equals to root 7 times root 7 times root 3 times 4 over 5 times 2. Root 7 times root 7 is 7, and 4 over 2 is 2, so I write it down. So the area of the green triangle FDE will be equal to root 7 times root 7 is 7. We have here root 3, and 4 over 2 is 2, all divided by 5. Okay, so the area of the green triangle equals to 7 times root 3 times 2 over 5 square units. So the area of the green triangle FDE will be equal to 7 times 2 is 14. We have here root 3 over 5 square units. Okay, so the area of the green triangle FDE equals to 14 times root 3 over 5 square units. Okay, or the area of the green triangle in terms of numbers. The area of the green triangle FDE equals to 4.85 square units. The area of the green triangle FDE equals to 4.85 square units. Again, the area of the green right triangle FDE, the area of this green triangle, equals to 4.85 square units. Okay, now I will summarize the lecture. Actually, we wanted to find out the area of this green triangle that is also a right triangle. Angle FDE of the green triangle equals to 90 degrees. It is a right angle, and we also know that the green triangle is inside triangle ABC, that is an equilateral triangle, and we also know that AF equals to BF, BD equals to 2 units, and DC equals to 4 units. And as you have already know, the angles, all the angles in any equilateral triangle equals to 60 degrees. So angle BAC equals to 60 degrees, angle ABC equals to 60 degrees, and angle BCA also equals to 60 degrees. Okay, and we also know that the sides of any equilateral triangle are equal to each other. That is to say, AB equals to BC equals to AC. Okay? And what is the size of side BC of the equilateral triangle? Actually, the size of side BC of the equilateral triangle ABC, the size of BC equals to BD plus DC. Okay, the size of BC is BD plus DC. But we know that BD equals to 2 units and DC equals to 4 units. So the size of BC equals to BD, that is 2, plus DC, that is 4. So BC equals to 6 units. Therefore, all the sides of the equilateral triangle ABC are equal to each other. That is to say, are equal to 6 units. That is to say, AB equals to BC equals to AC equals to 6 units. Okay, and especially AB equals to 6 units from one side, but we know that AB equals also to AB equals to AF plus BF, and we know that AF equals to BF. If we define AF as X, then BF will be also X because AF equals to BF. So what is the size of AB? The size of AB, it is AF that is X plus BF that is also X. That is to say the size of AB equals to X plus X, or the size of AB equals to 2X. So from one side we know that the size of AB equals to 2X, and from the other side we also know that AB also equals to 6 units. So from this equality we can derive that 2x equals to 6 units. And if 2x equals to 6 units, we can divide this equality by 2, and we found that x equals to 3 units. Okay, x equals to 3 units, that means that AF that equals to x equals to 3 units, and BF that also equals to x equals to 3 units. Okay, in the next step we defined FD as A and DE as B, and we found out the value of FD by using the law of cosines in triangle FBD. What is the law of cosines? The law of cosines is true for any triangle. We can say that in any triangle C square equals to A square plus B square minus 2 times A times B times cosinus theta. Again, in any triangle C square equals to A square plus B square minus 2 times A times B times cosinus theta. We can implement the law of cosines in triangle, the small triangle FBD. The implementation of the law of cosines in triangle FBD means that FD square equals to FB square plus BD square minus 2 times FB times BD times cosinus 60 degrees. Again, according to the law of cosines in triangle FBD, FD square equals to FB square plus BD square minus 2 times FB times BD times cosinus 60 degrees. Okay? Again, in triangle FBD, the implementation of the law of cosines means that FD square equals to FB square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay, but we know that FD equals to A, so FD square is A square. FB equals to 3 units, so FB square is 9. DB equals to 2 units, so DB square is 2 square. 2 square is 4. And 2 times BF is 3 and BD is 2 over cosinus 60 degrees. Cosinus 60 degrees is 1 over 2. So in total we got that A square equals to 9 plus 4 is 13 minus 2 times 3, and here 2 is cancelled, so we have in total that A square equals to 13 minus 6, so A square equals to 7. We took a root out of this equality and we got that A equals to root 7 units. A equals to the root of 7 units, and in the next step we defined angle BFD as theta, we defined angle BDF as alpha, and we also defined angle EDC as gamma, and the angle DEC is beta. And then we found the value of sinus theta according to the law of sines. What is the law of sines? The law of sines is true in any triangle. So in any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay? So we implemented the law of sines in the small triangle FBD. The implementation of the law of sines in triangle FBD means that BD over sinus theta equals to FD over sinus 60 degrees. Again, in the small triangle FBD, according to the law of sines, BD over sinus theta equals to FD over sinus 60 degrees. Okay, and we actually know all the values of the variables inside this equality. The only missing variable is sinus theta, because we know that BD equals to 2 units, FD equals to the root of 7 units, and sinus 60 degrees equals to the root of 3 over 2. Okay, so we put the data inside this equality, and we found out that the value of sinus theta is actually root 3 over root 7. After we found out the value of sinus theta, we also found out the value of cosinus theta by using special trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. Okay? So in this trigonometric identity, we subtracted from this trigonometric identity, we subtracted sinus theta squared, and we got that cosinus theta squared equals to 1 minus sinus theta squared. And then we took a root out of this equality, and we got that the value of cosinus theta equals to the root of 1 minus sinus theta squared. But we have already found out that the value of sinus theta is root 3 over root 7. So if sinus theta equals to the root of 3 over root 7, the value of sinus theta squared equals to 3 over 7. Okay? And here we can substitute sinus theta squared here by 3 over 7, because sinus theta squared equals to 3 over 7. And we got that cosinus theta equals to the root of 1 minus 3 over 7, or cosinus theta equals to the root of 4 over 7. The root of 4 is 2, so we got that cosinus theta equals to 2 over root 7. And we have already found out that the value of sinus theta is root 3 over root 7. Okay? In the next step, we created 4 equations from this drawing. The first equation states that the sum of the angles in triangle BFD equals to 180 degrees. So that is our first equation. We created the second equation by the statement that the sum of the angles in triangle DEC equals to 180 degrees. So that is our second equation. And then we added equation number 1 to equation number 2, and we created equation number 3, that is the addition of equation number 1 to equation number 2. And then we created equation number 4 that states that if we focus on a certain point along a straight line or line segment, at a certain point the sum of the angles on the upper side of straight line or line segments equals to 180 degrees. So if we focus at point D on the upper side of line segment BC, the sum of the angles equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, so our fourth equation states that the sum of the angles on the upper side of any straight line or line segment at a certain point equals to 180 degrees. So for equation number 1, we got that alpha plus gamma equals to 90 degrees. Then we substituted alpha plus gamma by 90 degrees in the third equation, and we got that theta plus beta equals to 100, theta plus beta equals to 150 degrees. We subtracted theta from the third equation, and we got that beta equals to 150 degrees minus theta. But if beta equals to 150 degrees minus theta, then sinus beta will be equal to sinus 150 degrees minus theta. And we found out the value of sinus 150 degrees minus theta by using the second trigonometric identity that states that sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. So we use this trigonometric identity in order to find out the value of sinus 150 degrees minus theta, that is actually equals to sinus beta. So we found out that the value of sinus beta is actually 5 over root 7 times 2. After we found the value of sinus beta, because we focused on triangle DEC, and we implemented the law of sines in triangle DEC, this triangle, in order to find out the value of DE, that is B. According to the law of sines, DC over sinus beta equals to DE over sinus 60 degrees. Again, in triangle DEC, according to the law of sines, DC over sinus beta equals to DE over sinus 60 degrees. Okay, we know that DC equals to 4. We have already found out the value of sinus beta. Okay, we found out the value of sinus beta. And sinus 60 degrees equals to the root of 3 over 2. And the only missing variable is DE, that is B. B is the only missing variable in this equality. So we put the data in this equality, and we found out that the value of B is actually root 7 times root 3 times 4 over 5 units. And we have already found out that the value of A is root of 7 units. And the area of the green triangle FDE equals to the base of the triangle, that is B, times the height to the base, that is A, over 2. Okay, so the area of the green triangle FDE equals to B times A over 2. And we have already found out the value of B and A, So the only thing that's left is to substitute A by root 7 and to substitute B by the value of B, and we found out that the area of the green triangle FDE equals to 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle FDE equals to 4.85 square units. Again, the area of the green triangle, this green triangle FDE, equals to 4.85 square units. Okay, thank you very much.